Okay. I'll just show you all the answers and then I'll go through them step by step. You also could have used different reasons for some of them, so you can just ask me if you did, and I'll tell you if it's fine. Yeah. Oh, yeah. It's okay, just quickly, I'm gonna show you my highlighting. I didn't want to highlight ahead of time. I wanted to do it like with you guys. So if we are having to find A, you will say that A is obtained by T, right, or T. But then that same chord, VT, also pertains to at the same time. Okay, so the angle at the center always has to be double the angle at the circumference. So that means that A is going to be half of 70. Right, so A is 35. Then I find out what angle at the center equals 2 times angle at the circumference. So B, you then need to look, okay, B is actually subtended by TR, which is the same length as VT. They show that on that diagram. So using equal chords, equal angles, you can say that B is also going to be 35. Equal chords, equal angles. Okay, next up we have to find C, right, which is subtended by chord BR. But then guys, if you notice that angle Q, the whole angle, which is A and B together, is also subtended by BR. So those two angles together will be equal to C. Alright, so C is 70 there because of the angles in the same segment. Then for D, this one was quite difficult to see because it's so like to the side, right? But if you're looking at D, D is also subtended by BC. Okay, so D is also going to be 35 degrees. Then I use the fact that this is an isosceles triangle to say that D is also going to be 35, right? Angles of 2 equal sides. But guys, for E, you're also going to say the equal chords, equal angles. Because E is subtended by TR, which is equal to. Okay, so you could have used equal chords, equal angles to that one, or just angles up to equal sides. Then define F, like I said, it was that whole angle there, because you have the other two angles in that triangle, 35 and 35. It is going to be 180 minus 35 minus 35. So that will give you an answer of 110 degrees. Angles are a triangle. And then to get G, it's again angles in same segment. And now we are looking at this. Oh, into rectangle angle G, right? Those lines meet up to point G, but the same arc subtends that 22 degree. Yeah. Yes, you could have, yeah, because you already have that. Okay, I will wind it up on guys. Any questions on any drawings? All right. Okay, I'm going to show you guys the new theorem today, one of them. Not the proofs, we do still have to do the proofs, I know that. I just want us to practice them first. So you can write cyclic quads or cyclic quadrilaterals, I suppose is better, as your next heading. And then we're just going to talk about that and practice.
Oh, it's Mr. Kuma's birthday today. So if you guys see him, just wish him.
Okay, guys, so just a cyclic quad, you've never worked with something like that before. Cyclic quad, it is a quad with all four vertices, so all four of the points, right? A quadrilateral is a shape with four sides, so therefore 4 points, all right, four vertices. So if a quad is a cyclic quad, then it has all four vertices on the circumference of a circle. I just want you to add just in brackets, and I will explain this part later on. The circle does not have to be drawn in. So that might sound a bit strange, but sometimes you just have a shape with 4 points and they ask you to prove that it is a cyclic quad. So then they don't actually show you this one. I have to go into that still. So now we're going to just talk about a few theorems that we are going to use when we're working with cyclic quads. So of angles of cyclic quad, that is the one theorem. Now this theorem says that the opposite angles of a cyclic quad add up to 180 degrees always. And that's the reason, right? The reason is of angles of cyclic quad. Okay, when we're using that, we are going to do examples. Now, if they are asking you to prove that something is cyclic quad, we're just going to work the other way around. So I'm just going to write in blue there, therefore, if the opposite angles of a quad at up to 180 degrees it is a cyclic chord. And basically what that means is that a circle can be drawn going through those four points. But I'll show you on the pictures also. If you're confused, don't stress. Okay, then the other theorem that has to do with cyclic chord is exterior angle of cyclic chord. Again, that is the reason that you have to write down if you're using it. Now, what this theorem says is that the exterior angle of a cyclic chord is equal to the opposite interior angle. Just radical angle. Okay, so that means that if you have a cyclic chord, right, all four points are on the circumference of a circle, then the exterior angle will be equal to the opposite interior angle. I'll show you now on the picture how that works. And then like the opposite will also be true, right? So if this happens, if you have any chord, it doesn't have to be drawn on a circle, any chord, and the exterior angle is equal to the opposite interior angle, then it is a cyclic chord. Okay, so I'm going to put that in blue again. So therefore, is the exterior angle of a quad is equal to the opposite interior angle it is a cyclic chord. Which again just means that you could actually draw a circle going through those four vertices. And we're going to do an example. Sorry, I'm going to ask you guys to do it. It's not a very complicated one. There aren't like a million lines. Like the last one that I asked you guys to do. It's just a circle with a quad in it. So if you can just write the example. Actually, let's say example 1. So that's noted for that. This speed as well.
All right, guys, I'm just doing absentees quickly before I forget. Is Sophia at school? No. Do you know her? Sophia. That's fine. Okay.
Are you guys done copying as well? Okay, guys, now A, B, C, D, right, that quad. As it's drawn here, we can see that A is on the circumference, B is on the circumference, C is, and D as well. All right, so all four of the vertices of the squad lie on the circumference of the circle. So A, B, C, D is the cyclic quad. Okay, we can tell that just by looking at the picture. All right, so that means that we can use properties of a cyclic quad here. So if we're needing to find x, we have the opposite angle, right, to x. So sometimes it's not as easy to just that it's opposite. Sometimes you see the cyclic quads are drawn quite like thin, I suppose. So you're always looking for the angle that's obviously not next to it, right? But opposite. Okay, good enough. But sometimes it is a difficult to see. So these two angles have added to 180 degrees. So if you want to find the value of x, we're going to say x is, and this step you don't have to write down, but since it's the first example, let's just all write it down. 180 minus the angle that's opposite that one. The reason is going to be of angles of cyclic quads. And that answer is then 90. So once we calculated that angle, like before, we can follow that thing on our. Okay. And next up, we need to find y. How can I do that? And we're on a straight line, right? So y and 100 degrees are on this straight line. So then let's add it to 180. So I'm going to say here that y is going to be, and again, this line you don't have to write down, but you can if you want. 180 minus 100. The reason is angles on a straight line. So y is then going to be 80 degrees. And then if we wanted to find z, all right, there are actually two things that we could do here. So I'm going to fill my 80. Could have used opposite angles with a cyclic quad again, right? If you wanted to, because, oh, sorry, Z and 80 are now opposite, so Z is going to have to be 100. Or guys, you could use exterior angle of the cyclic quad. Now, just like with a triangle, an exterior angle is what happens when you have a side of the quad that's lengthened. Okay, we have to go. All right, so BC is the side of the quad and they've lengthened that side. Okay, you can't have like a line going up like that and then say that that angle there is the exterior. Okay, that won't work. It has to be a side of the quad that's been extended on the outside of the quad, like we have here. BC is extended to point E, right? And then we have that angle on the outside. So this is an exterior angle. All right, and what did we write down? We say the exterior angle of the cyclic quad is equal to the opposite interior angle. So the exterior angle is 100 degrees, sorry, and the opposite interior angle is this. Okay, to find the interior angle, you look at the one that's next to the exterior angle, and then the angle opposite to that. Okay, so we are going to practice it still a bunch today, but we can use both. We can use opposite angles in cyclic quad, say that these two is added to 180, which will give you Z is 100, or you can use exterior angle of the cyclic quad to say that these two must be equal. Okay. So Z is going to be equal to 100 degrees. Okay, any questions on that one? I'm going to give you guys time to just practice, just using basically these two theorems together. So it is exercise 4. Just see here, because I have okay, there is number 1, guys. You can do number 1, please. I see someone did write one answer in there. But do you have another? Okay, sorry. Alrighty, you guys stationary today. Okay, guys, there's number 1. Do that one. And then I'll move it up to number 2. So you have to find W, X, Y, and Z. I will just quickly pull in where those letters actually are. Just take them. So that is number 1. This one. That is number positive. So I'm not going to give you that. But I didn't have that one off yesterday. Too very good. You have some demo as well. But as you can notice that we have two different types of plots in this question, right? We have A, B, C, D. Right? How do I recognize them as a cyclic plot? 4 points, and I always define. Yeah, it has to be 4 points. Obviously, if it's 3, then it's a triangle. Okay, then it's not a cyclic plot. So A, B, and D, all 4 of those point lines are happening in the circle. So this is a cyclic plot. It always looks like a line, right? That's one. Okay. Then we have another one. C is B and A. All 4 of those point also lines. So that also forms a cyclic plot. So you can use the different, you can, oh, actually, we do not have a lot of money. Which one is going to be? One supposed to be added in, sorry, if I organize correctly, I will go on, but it's actually information that was nothing. So if you have your things prepared to find the useful in a one thing, and actually do everything. So, I'm going to get that with the, okay? So they were supposed to put in that one thing. So you can use opposite angle cyclic plot in this one, and not try to find in this cyclic plot, and then you have one. Guys, you're doing number 1. I'll put number 2 on the board a little bit later, but then also from that target worksheet, remember we did the first 3 questions together in class. I would like you to then also do now. Yes.
C equals 100 minus 3.
Very nice. We were the one that we took that. So it was exterior angle cyclic plot. So guys, you're doing, just listen up quickly, you're doing numbers 1 and 2 of this exercise. All right, so that's 1, 2 is up, is there at the bottom. I'll move it up just now. And then from that target worksheet, we did 1, 2, and 3 together in class. Right? That you stuck in. I would like you to maybe just get it quickly so that you can circle the ones that I want you to do now from that one. So after you finish 1 and 2, you're going to do 4, 5, 9, and 10. 4, 5, 9, and 10 of the target worksheet. So 1 and 2, and then 14, 4, 5, 9. And guys, for the target worksheet one, we're gonna have to check out your other theorems as well, the ones that we practiced before these 2 ones. Okay.